All right, so before we get started, I want to excuse the glare. The sun is kind of shining. This is question 6 from your classwork, which turned into the homework. We're going to look at this as the word problems. We're going to work through these together. So these are the masses of the inner planets of the solar system. We have Mercury, Earth, Venus, and Mars. The first question says, what is the difference in mass of Earth and Mars? So when I hear the word difference, I automatically know that is subtract. I'm going to be subtracting those two quantities. And I'm going to look at Earth. Earth is 5.9722 times 10 to the 24th kilograms. And Mars is 6.4185 times 10 to the 23rd kilogram. So what I'm going to do is I'm going to subtract the mass of Mars from the mass of Earth because Earth is larger. So the first thing I'm going to do, they are both written in scientific notation. First thing I'm going to do is rewrite my expression as 5.9722 times 10 to the 24th power minus 6.4185 times 10 to the 23rd power. Automatically, I notice that these two exponents are not the same. So the first thing I need to do is change them. So I'm going to rewrite this exponent 10 to the 24th. I'm going to rewrite that over here to the side because I'm going to have to break that down. And when I'm figuring out what to break it down into, I look at the other exponent, which is 10 to the 23rd, because I know I want it to match that. But I know it still has to equal 10 to the 24th power. So what I'm going to do is I'm going to think to myself, what plus 23 is going to give me 24? Or you could just subtract 24 minus 23, which is going to be 10 to the first power. Then I'm going to bring this number over 5.972. I'm just going to write that directly in front of that. And so now I have 5.9722 times 10 to the first power times 10 to the 23rd power. And when I'm multiplying something times 10 to the first power, that means I just take my decimal, and because it's a positive, I'm going to move it to the right one time, which is going to give me 59.722 times 10 to the 23rd power. This first power cancels out when I move my decimal. Now I'm going to rewrite the subtraction. So I'm going to put minus 6.4185 times 10 to the 23rd. And put that 0 there just so that it's easier for me to subtract. 0 minus 5, I can't do that. I'm going to borrow from the 2. The 2 becomes a 1. 10 minus 5, I can do that. That's going to be 5. 1 minus 8, I can't do that. I'm going to borrow from the 2. The 2 becomes a 1. The 1 becomes 11. 11 minus 8 is going to be 3. 1 minus 1 is going to be 0. 7 minus 4 is going to be 3. Bring down my decimal point. 9 minus 6 is 3. 5 minus nothing is 5. 53.3035 should be my answer times 10 to the 23rd power. The next question we're being asked is, what is the combined mass of Venus and Mercury? So I know that combined tells me I'm going to be adding these, so I'm going to be putting them together. And Mercury, 3.3022 times 10 to the 23rd, and Venus is 4.865 times 10 to the 24th. And I'm going to rewrite that just like I did in the last problem. I'm sorry, 685. Now again, I have that issue of these two exponents not being the same. I'm going to go ahead and break down that 24th power again. I'm going to break that down into 23, because remember 10 to the 23rd power, because remember I want that to be the same as whatever exponent I'm keeping. And then 24 minus 23 is going to be 10, and then that's to the first power, 10 to the first power. And I'm just going to bring that number over my coefficient 0.8685, and I'm going to multiply those. And I know that this number is going to be equivalent to this number. Because this stuff is in parentheses, I'm going to go ahead and simplify this expression. I'm going to move the decimal over one time, so that's going to end up being 48.685 times 10 to the 23rd. Don't forget that cancels out when we move that decimal over. I'm going to bring over my other number so that it can be easier for me to add. And I'm going to make sure I'm lining up that decimal. 3.3022 times 10 to the 23rd. Now, a lot of you are confused. This does not change. And I'll explain that in just a second. So we just bring down the times 10 to the 23rd power, and then we add these numbers. I'm going to put a 0 here to help me. 0 plus 2 is 2. 5 plus 2 is 7. 8 plus 0 is 8. 6 plus 3 is 9. 8 plus 3 is 11. Carry the 1. 4 plus 1 is 5. This is my answer. So a lot of you may be thinking, why don't we add these or subtract these or divide these? Why don't we do anything with these? So say, for instance, if I had 2.1 times 10 to the second power plus 3.2 times 10 to the second power. What I'm really saying that I have is 2.1 times 100, or 210, because if I move that decimal over twice, twice, I put a 0 in the hole, that's 210. 3.2 times 10 to the second power is the same thing as 320. Move that decimal over twice, twice, put a 0 where the space is. If I add these up, I'm going to get 0 plus 0 equals 0, 1 plus 2 equals 3, 530. If I add these decimals up, 2.1 plus 3.2, I'm going to get 0.3, 5.3. And then that's why the reason why I keep it the same, because this is 530 is the same thing as 5.3 times 10 to the second power, because I will move that decimal twice to the right. So it will be 5.3 once, twice, 0. The same 530 I had when I did it this way. So please just make sure you are keeping the exponents the same, because if not, your answer will be incorrect.